Hi, welcome to a shop. This is another all around the shop episode. This is just some talking and maybe some hands-on work. But first of all, I have to thank you all. I just got over 800 subscribers and I'm blown away. I get so much very good feedback from you and I appreciate every single comment, and I also try to answer most of them. Sometimes I forget to answer a comment, but that's not on purpose, it's just I forget it. I try to answer everyone and I try to keep that up, so I would be very happy if you keep the comments coming. So thank you all very much. This is awesome. And now for the shop. This was a pretty busy week, but I didn't get much done in the shop. Just some infrastructure things. First of all, I built a new shelf. Okay, we're over at the milling machines, and this is the shelf I built. It's built out of 18mm softwood. The ends are rabbited in the side pieces, and everything is screwed with 6 70mm long screws to the concrete wall, so this thing shouldn't go anywhere. This will hold most of my milling machine tooling, the setup tools, vices, my rotary tables, the forward axis, and stuff like that. Just some of the stuff that's in these shelves up there. And the last time I'm pretty worried that these might come down, and I want to put some relief on them. Back from the shelf, and I want to try to get a bit into woodworking, wood chucking. I tried my hands on a simple dovetail just with handsaw and chisel, and it's a so-called 2-meter dovetail. From 2 meters away it looks kinda okay, but if you get closer you can see that here is a gap that's about 7/10 of a millimeter. There is a gap. Here it's not too bad, but at least it's almost square and it's completely cut by hand. So and I enjoyed it also, so maybe I will do some wood chucking in the future, but this will mostly stay a machining related channel, so don't be afraid of that the woodworking will take over. I will try from time to time to do something with wood, if I'm in the right. Next thing is I got this from eBay. It's a Mitutoyo, of course, because I really love the measuring tools made by Mitutoyo. They have something to them that's just right, and it is a 0 to 25mm disc micrometer, disc style. You use this to measure between 2 thin slots, and you can also use it for gear measuring and work the small steps that are flush to a surface. You can get pretty close with this and take a measurement. And what I like about the Mitutoyo ones, when you turn the thimble and move your spindle, this This measuring spindle actually stays still, it doesn't rotate, it's just moving in and out. Just to show you, I make a small point, a blue point here on this disc, and as you can see, when I turn the thimble, the spindle doesn't rotate, it does just move in and out. This is a very nice feature because there are disc micrometers where the spindle rotates and they tend to get crooked on the part while you tighten the micrometer, while you take your measurement. And with the still standing jaw, this doesn't happen. So it's overall in a not perfect shape. It gets some encrustation here on the spindle, and even worse, it got some here on this measuring surface. But I don't think it's too bad. I will get my fine ruby stone out and clean this off. The Mitutoyo boxes always have this problem that the foam disintegrates within time. That's the only drawback with Mitutoyo tools. Okay, not with tools, with their toolboxes. There is a 25mm standard in the box, and I will check this if it's on the spot. I'm using my digital 1000mm micrometer to check it. First, I clean the measuring surface with a piece of paper. Just close it, ratchet it onto the paper and pull the paper out. And then you can see that there is some dirt on the paper that was on the measuring surfaces. So if I close it now, the micrometer shows 0.002 millimeters, and that's also pulling these surfaces over a piece of paper to clean them. And to take a measurement. And the micrometer shows 24.999 millimeters, and that's spot on. I know that some people will freak out when I use a stone on the actual measuring surfaces, but in the current status or state, this micrometer is useless with the encrustation on the surfaces. So first I'm going to try a Shoptalk with some good old WD-40. And it doesn't look like it will clean up because it's in there. So I'm going to take my ruby stone. This is incredibly fine, so I don't really worry to destroy anything on this micrometer. Actually, I'm going to close the surfaces on the ruby stone. Maybe put some WD-40 on it and close it on the stone. Okay, I think that's it. Now close it up on the piece of paper and take out the oil and the dirt between the measuring surfaces. Let's do it again. Okay, and now we try to zero it. And it pops right to 0 and overshots by half a hundredth of a millimeter. Oh, that's not too bad. Let's check it with a 25mm standard. Yeah, it overshots also slightly, so I'm going to calibrate this micrometer. Okay, you all know this. This is the wrench that comes with the micrometer, and I'm just noticing that this micrometer doesn't have a lock. Interesting. I never realized that. Okay, I'm going to put the standard in. Take my measurement, and now it's just a matter of turning the inner barrel with this wrench. It's a spanner wrench, a tiny spanner wrench, and you have a hole here on the barrel of the micrometer, and you just hook spanner wrench in, and oh yeah, and most of the time okay, let's see. Okay, that's exactly 0, and let's check it if it works also when I'm measuring on the edge of the disc surfaces, and it shows slightly below 0. So that's in fact very good. I'm very happy with that. Yeah, let's clean it again and turn it to 0, and it goes to 0 right away. So this micrometer is more than good enough for my needs still. 21st May 1974. Maybe that's the date where this micrometer was purchased, or the date of the last calibration, I don't know. I got this from eBay. Also, here is the original label from Mitutoyo that says made in Japan. And overall the box is in very good shape, except for the disintegrating foam. I don't know what to do about it yet. I will come up with something. Maybe I will scrape it out and put in some green felt, also down here on the bottom. I will see. I will just, yeah, it's dirty. It's really dirty. I will just use some WD-40. Just give it a wipe. Foam is a mess. I need to do something about it. That's also some of the foam that fell out of the lid. That's getting messy. Okay, I'm going to rip out the foam. I'm using a single edge razor blade. I ripped out most of the foam. I can do new foam over this. They use some kind of a very sticky glue, and I don't think that I will get this out without much hassle. So I'm just leaving it in and putting something over it. I'm also cleaning up the foam insert very lightly. Let's see if I have some foam here. That's at least enough foam for the bottom. And I'm going to cut it. I need a first square it up. Okay, and it also seems to have the right thickness. There we go. That problem solved. I'm using Micrometer 50, that's for rubber. And as this is some foamy stuff, I think that might work. Just put in a good amount. That already is. A bit of a hassle, but this is not a precision application, and it fits. And it closes up. And I'm going to glue this also to the lid, so I don't lose it. Okay, I have two more things. I filmed these some time ago, but I never got around to upload them, though I will include them in this Shoptalk video. One is the replacement of the spring in a edge finder, or in two edge finders, and the other one is cleaning some parts with the Ultrasonic cleaner and how well that works. So first, the edge finders. This is the aftermath to my edge finder repair last week, where we relapped the sliding surfaces of this small edge finder. I used this since then a few times and it works very well again, but we still have these two edge finders left with the broken and bent springs. I looked the replacement springs from the manufacturer up, and they are $3 a piece, and that's not reasonable in my mind. I took the measurement of the original springs and ordered some nearly the same size springs from a generic springs from a hardware dealer. So let's put these back together. Okay, we go first with this one. This is the front portion, and it already has the pin in it, and the pin sticks halfway into the central bore. I take my spring, my replacement spring, I move it in, and I try to catch the pin with the loop of the spring. So it seems that I got it, and now I'm going to press the pin back in, and of course the spring jumped off. This is kind of tricky. Okay, I got the spring catched with the pin and the pin also pushed in almost all the way. The last bit, it needs to be pressed or hammered in. I'm just using a piece of brass as backing, and now I have my spring in there. Now the trick is, again, as with the smaller edge finder, use a piece of baling wire, bend a loop on the end, stack everything up. First we want to put some loop on the sliding surface. Okay, put the shank part over it and pull the spring back. Now you need to catch the spring with your hand, release your hook, get your end plug into the hook of the spring and let it snap together. And there you have a repaired edge finder with a new spring, and it feels great. In fact, it feels that the spring is almost perfect. Okay, one done, one to go. There you have it, 2 repaired edge finders, and of course my smaller 6mm edge finder. That's an easy fix, and a spring in the dimensions that's needed for the edge finders can be found on eBay or purchased on every hardware dealer for a few cents. So no need to buy the $3 spring from the manufacturer. So I still have one replacement spring and I'm ready to go again with my edge finders. Okay, there you have it. My 2 10mm edge finders, repaired and back in use. Both work very nice sliding action on the mating surfaces, and also my smaller 6mm edge finder that I already used quite a lot after repair, and it works flawless. This is just to show you that you can very easy repair these edge finders when you crash or bend the spring or you mangle up the sliding surfaces between them. So they are not in every case to be thrown out. That helps somebody out. That was the footage of the edge finder repair, and now we're going to see the use of a ultrasonic cleaner. This time I wanted to tackle the subject of ultrasonic. We have some crusty parts over here that we will throw in later and take a look at it, how they came out. The ultrasonic is filled on with water. It has a ultrasonic generator in it, and the water bath is heated. So I already turned this one on and the water is up to about 80 degrees Celsius. If you get an ultrasonic cleaner, make sure you get one with heating. Without heating, they're next to useless. Most of the cleaners used in them work only with hot water. If you have one without heating, you need to use hot water that's already hot, or drop in a heater element, or you can just use cold water, which is very disappointing. It's just plain water, no cleaner in it, and I will not put cleaner into this water because the cleaner is pretty expensive, and I don't want to waste a whole lot of it. As I'm going to do a lot small parts, I'm using a glass jug, a 125 milliliters jug, fill it with a bit of water and a bit of cleaner and drop it into the bath. So I have my cleaner in this glass and it's surrounded by plain water. There's also a neat trick to check your ultrasonic cleaner for power, because the ultrasonic generators in these things wear out. They have a lifespan, and you can take a piece of aluminum foil, standard kitchen aluminum foil, drop it in and turn on the ultrasonic generator. And then you let it run for a few minutes. And as the ultrasonic cleaner is running, you will see that there are holes generating in the foil. The foil is falling apart and it's getting holes. As you can see up here, there is already a big hole in the foil, and also down here. And also down here, it's starting to degrade. If we leave this in a few minutes, it will really be a wreck. Okay, as you see, up here and here, here, the aluminum foil is eaten away pretty fast. This ran about 10 minutes, and the aluminum foil got this huge hunk here missing and a few holes, and also down here started to get eaten away. So this is an easy short test if a ultrasonic cleaner has any power left. Okay, now we will do some actual cleaning. Okay, this is the cleaner I'm using. This is Pur TR3. It's a ultrasonic cleaner that's based on citric acid, and it's good to remove heavy encrusted dirt, rust, grinding dust, and it also removes gun bluing, gun blackening, gun browning. Browning is the right term. And overall you just get a clean part of it. You can't leave your parts too long in this cleaner, because after maybe an hour the parts get black, and this black surface is very hard to get off, so 10 minutes to a quarter hour is the right time for this. It's you don't use it straight, you dilute it down to 5%. So this is 125 milliliters. 5% are about 5 milliliters, 5 or 6 milliliters of cleaner. Yeah, here is 50 and 25. This might be a bit heavier than 5%, but this is okay. Now we're just filling it up with water up to 125 milliliters. Okay, 125. As you can see, this cleaner is irritating. It's not too aggressive, but I'm still wearing gloves because why take chances? Over here I have a collection of parts I'm going to drop into the cleaner. Here is an ER20 collet that's pretty badly rusted up. It has pretty much rust here on the front and also some dirt and corrosion on the surfaces of the taper. So let's drop this in. And here are my parts of my screw jacks. As I made these are shop made, I did some gun browning on them, some blackening fluid, and it came out pretty ugly. It's more a rusty like brown tone, and I want them to be bright metal again, so I'm going to drop these in too. Here's my glass with the cleaner and some of the parts in it. Okay, and as you can see, I didn't have to fill all the 2 liters of this unit with the cleaning solution. It's enough to fill the small jug with it. So let's turn on the ultrasonic cleaner. And you can right away see that there is some cleaning. Now you can see that the solution gets pretty dark right now, and this is all the rust and dirt that's solved from the part. Okay, we are about 10 minutes in and we're going to take a look. I'm switching off the ultrasonic cleaner and we will take the parts out of the cleaning solution. Okay, here we are. I'm using a pair of long tweezers to fish out the parts, and this is the ER20 collet, and you can see right away that it looks way better than before. Almost all of the crud is gone, just some around here where it was very heavy. There was very much buildup all around here, and also around here where it sat in the collet holder. Around here there was a lot of buildup. I will drop this one back in the cleaner later, but first we will take a look at the other parts. There we have a very nice part. As you remember, these looked like this before with the rust-like finish, and now they are nice and clean, down to bright metal. And when you take these out of the cleaning solution, you need to oil them or they will rust later. Right away when I pull them out of the cleaner, I'm using WD-40 to displace the water. That's what WD-40 is made for, and later I'm going to oil it or put some Vaseline on it. That depends on the part. This might just get a rub with whey oil to give it some rust protection. Okay, that was all. As you can see, all the parts came out very nice, and also this collet looks pretty good again. I'm going to drop it in again with some of the other parts, just to give it some more time in the cleaning solution. I left the ER20 collet a bit longer in the solution, and now I'm going to pull it out. And as you can see, it's pretty okay. Most of the heavy corrosion is gone. The surfaces are clean. One side effect of this cleaning solution is that polished surfaces get somewhat, they get a bit more of a satin finish. They get a bit dull. But it beats hitting a colored with Scotch-Brite by any means. With this process you don't have any abrasives or any grinding dust on your collets, and that's something to avoid in any way. So I think the ultrasonic cleaner is one of the best ways to clean precision parts. Okay, I've cleaned the collet with some WD-40, and now we take a closer look at it. As you can see, the tapered surfaces are pretty clean, except for this ring around here where the collet holder ended, and that's where some of the corrosion has some of the collet material eaten away. This is rough in here. Of course the ultrasonic cleaner doesn't put metal back on, but as long as it's deeper than the surrounding surfaces, you won't have a problem with accuracy. This area is then just relieved behind the mating surfaces. This front tapered portion is also pretty clean. On the front face we have some pitting by the corrosion, but also, as heavy as this collet was rusted and gunked up with dirt, I think this is a pretty good result for the ultrasonic cleaner. And here to take a close look on my screw jack parts. These came also out very nice. They are down to bright metal, and even here in the threads there is nothing left of the ugly brown finish, and that's what we want. We're back. As you saw, the ultrasonic cleaner does a very good job of cleaning small machinery tools or machine tools and work holding devices and tool holding devices, and just all around in the shop and around in the house. Ultrasonic cleaner with a good cleaning solution is a very viable tool, and if you can get one with a heater and a bath that's big enough. Mine is a 2-liter unit, but I would go for a 3 or 4-liter unit the next time. So yeah, that's it for this episode, and feel free to comment. I would love to see your comments, and thank you for watching. See you next time.